Imagine a place where everything that you ever needed was there for you. Would you call that place Shangri-La, Utopia, or Paradise? Or would you call it simply Earth? Planet Earth is a marvelous place. To our knowledge, it is the only place in the entire universe that can sustain life, and our climate is part of what allows this to happen. I'm Don Heath. Earth's climate is now in danger. But why is that? Is it because of humanity's lifestyle? Or is it a natural phenomenon that occurs and reoccurs over time? To date, there is no clear answer. Because of this, many people believe that climate change is nothing more than a myth. After nearly a decade of research, stellar mechanics will give us some of the answers that we seek about this question. But first, let me say that stellar mechanics is not a study of climate change in itself. Stellar mechanics studies how our solar system has evolved from the explosion of a single star, a supernova. Earth's climate is the result of a chain reaction that occurred during the long, slow evolution of our solar system. It began to evolve at the very beginning of Earth's history and continues to evolve today. Understanding how our solar system was created is a major key into understanding how our climate truly functions. For this reason, climate change will not be in our focus today. Rather, everything that occurred allowing our planets to have climate. To do this, we must go back in time some 5 billion years, back to when our parent star was born, a star that would give birth to an entire system, a system with planets and moons, comets and asteroids, and everything needed to create life, all governed by a new star, one just like ours. When examining objects that are outside of our solar system, there is something very important to remember. These objects are very, very far away. This means that we cannot see them in real time. For example, this image of the Crab Nebula is a distance of 6,523 light years away from us. This means that we are seeing it as it looked 6,523 years ago. We cannot see what it looks like today because the light emitted from it will not reach us for another 6,523 years. Therefore, since we are only able to witness an instant of time from any single object in the universe, we must view many objects, each of them at different stages of their own evolution, in order to paint a clearer picture of what is happening around us. These are hydrogen stars, the first phase of a star's life. They are formed from giant clouds of pure hydrogen, the most abundant element in our universe. They are very, very hot and bright white. They have short lifespans, but during their lives, they go through remarkable changes. In this star field, many of them are not white. The colors are an indication of how far along a star is in its own evolution, or rather, how old it is. White stars, blue stars, green stars, orange stars, red stars, yellow stars. A star changes color because of the chemical reactions that are taking place on the inside. New elements are being created. Helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. These reactions continue through a total of 26 elements. Once the reaction reaches iron, the star turns red and reaches the end of its life. When a star goes supernova, it turns 26 base elements into the 92 elements and countless molecules which make up all the matter that we know. These elements and molecules are spread throughout a vast area, sometimes measuring tens of light years across. These explosions are so powerful that they literally rip the stars apart. But the stars do not completely vaporize. They leave behind several traces, notably the core, a neutron star. The core has been crushed down to almost nothing, but it's still there, and spinning very, very rapidly, perhaps dozens of times per second. Neutron stars will eventually regenerate themselves into stars like our own sun, and the new star system will form from the remnants of the parent star's supernova. It can do this because, although it is very, very small, the neutron star is highly magnetic. Its magnetic force is second only to that of a galactic black hole. Over time, This magnetic force will reattract nearly all of the matter that had been expelled by the supernova explosion back into itself, producing a second-generation star, one just like our Sun. But in order to produce planets, something amazing must take place. This match burns because the flame is fueled by a solid and a gas. It will continue to burn until the wooden fuel source is exhausted. The flame from this lighter burns because it is fueled by two gases. When the butane is exhausted, the flame is extinguished. These things happen on Earth because we live in an oxygenated environment. Oxygen is the common denominator. Without its presence, nothing can burn. In space, things are different. There is no oxygen. This star burns because the oxygen required is on the inside, and when a star goes supernova, all this matter is spread over a vast area. Most are in the form of gases, but some remain solid, like these. These points of light, expelled by the supernova, contain many of the elements and molecules that were blasted out into space, including oxygen. For this reason, they can continue to burn. These sparks of matter are large enough that their oxygen levels can allow them to continue burning. But these are not just flaming bits of matter. These are protoplanets, the first stage in a planet's life. They are self-sustaining and will continue to burn as long as their oxygen supplies remain intact. This is the miracle of planet birth. Over time, these protoplanets will collect more and more matter as the neutron star draws everything within its magnetic grasp inward towards the center. From this point forward, the brand new star system will be locked in a battle between the pull of the neutron star's magnetism and the push from the energy expelled by the slowly growing star. And as this matter is drawn in towards the center, these protoplanets basically feed on the lighter material as they all move closer to the star, gaining in size and strength. All this matter is trying to do one thing: return to the star. In doing so, a sphere is formed around the slowly growing star, a heliosphere. This heliosphere becomes the outer boundary of the new system, just like our system. In our star system, the distance between the star and the heliosphere is about 2 light years, which makes the diameter 4 light years. This is an enormous amount of space, yet these new systems can be much larger, and they still have quite a way to go before we recognize them as solar systems. The heliosphere will continue to contract, and the matter becomes more and more concentrated. Now the growing star's rotation begins to act on the surrounding concentration of matter. This star is still spinning very, very rapidly, perhaps dozens of times per second. This whirlpool effect causes the sphere to flatten, bringing all of the matter closer to the star's equator. This process is very long and very slow. Even today, one orbit of Pluto around our Sun takes about 250 years. The matter continues to flatten and becomes even more concentrated. A molecular cloud has now formed, containing all of the elements and molecules that we know of today, including carbon, oxygen, and water. Over time, the protoplanets that are within the cloud will be cooled down by it, but only on their outer surface. The interior continues to burn. Only now is a planet like Earth born. a ball of fire that is encased within a shield of solid rock. The planet is now protected from being extinguished. That's because this cloud is cold, freezing cold. Although the star is gaining in strength, it's not yet strong enough to heat a vast area. The rotation of the cloud creates wind on the planet's surfaces. They now have climate, icy cold and very, very windy. By the time that the cloud finishes its journey back to the star, the planets will be covered completely with ice. Only when the star reaches its full strength and radiating immense heat will the icy surfaces of the planets begin to melt, leaving worlds covered with water, just like Earth. These climates will continue to evolve depending on how far away from the star they are. Mother Earth is alive, but if we don't take care of her, then she will no longer be able to provide us with all of the things that we need to live. I guess that the biggest question of all is simply, what are we going to do about climate change? One thing is certain, Earth's climate is declining more rapidly than we think, and because of it, people are dying. Working together, all of us together, is the only way that humans will defeat climate change. I designed stellar mechanics to help us learn more about our world. In the future, we will be able to defeat climate change. Of this I am certain. I'm Don Heath.